In this video, we're going to talk about solving a rational equation that will simplify into a linear equation and then also into a quadratic equation. In our particular book, this is Chapter 5, Section 5. So what we have is an equation that deals with a variable in the denominator. I'm going to write this twice because there are two ways to deal with this. The first way, which is the most traditional way, is we look at this, and this is negative 2 divided by v. To undo division, we multiply. So I get negative 2 is equal to negative 6v. Now I still need to isolate that v, so I'm going to divide both sides by negative 6. And I get v is equal to positive 1/3. Now the second way we can look at this is that if I have negative 2 over v is equal to negative 6, you'll notice kind of in this step I ended up with negative 2 over negative 6 equals v. If you have your variable in the denominator and it's set equal to a single constant or number, nothing else is going on, you can simply switch their places. Which is kind of what we had right here once these 6's canceled, giving me v equals 1/3. Both methods are completely correct. This method is basically doing all of this just sort of in your head. So let's try another one of those. I have 6 over u is equal to negative 4. Traditionally, I'll multiply both sides by u, giving me 6 is equal to negative 4u. Then I'll divide both sides by negative 4, giving me 3 halves. That's negative 3 halves. We don't leave that negative down lurking in the bottom. We'll move it up, is equal to u. Or taking the shortcut, I get 6 over negative 4 is equal to u. So negative 3 halves is equal to u. Now, this type is a little bit more complicated. Here we had just a single variable in the denominator. Here we have a variable expression in the denominator. The process is pretty much exactly the same though. I'm dividing by w minus 4, so how would I clear w minus 4? Well, I'd multiply both sides by w minus 4. Giving me 8 times w minus 4 is equal to negative 1. Now I could distribute in that 8, or, well, actually with this method it's best. I'm going to distribute in that 8, and I'm going to get 8w minus 32 is equal to negative 1. So 8w is equal to 31, because I'm going to add 32 to both sides. Dividing by 8, I get w is equal to 31/8. Now, I can use that same sort of shortcut method that we used on the other problems. If we do this, we're going to be dealing with adding and subtracting fractions, which is completely fine. I'm going to switch the w minus 4 and the 8. So I add 4 to both sides. But now if I add 4 to both sides, I have w is equal to 4 minus 1/8. need to convert this 4. So I'm going to multiply it by 8, and I get 32 eighths minus 1 eighth. So W equals 31 eighths. Both methods get you the same answer. They're both completely legitimate. Let's try one more. Negative 4 is equal to 1 over y plus 3. So I will multiply both sides by y plus 3. So I get negative 4 times y plus 3 is equal to 1. Negative 4y minus 12 is equal to 1. Negative 4y is equal to 13. Divide both sides by negative 4. Y is equal to negative 13 fourths. And just to be clear, I got the 13 by adding 12 to both sides. Or using our other method, I get y plus 3 is equal to 1 over negative 4. Subtract 3 from both sides, and I get y is equal to negative 3 minus 1/4. Negative 3 turned into a fraction with a denominator 4. I do 3 times 4, so I get negative 12 fourths minus 1/4. So y is equal to negative 13 fourths. Okay. For our next type of problem, we've got a lot going on here. I have a y minus 6 in one denominator. That equals 4 over 3y minus 18 in another denominator, and then I have this whole number, 2. What I'm going to do is I'm going to put my two fractional terms together. So I'm going to subtract this 4 over 3 minus 18 from both sides. Okay, so basically I moved it from one side to the other, and it was positive here, so it's negative here. Now if I look at this 3y minus 18, y minus 6. 3y minus 18 is the same thing as 3 times y minus 6. I have y minus 6 right here. So in order to give these a common denominator, I can multiply by 3, and I get negative 6 over 3y minus 18 minus 4 over 3y minus 18 is equal to negative 2. Negative 6 and negative 4 is negative 10 over 3y minus 18 is equal to negative 2. Now, this is going to be one of those cases where switching these places is actually going to be very beneficial to us. We switch those. Negative 10 divided by negative 2 is 5. I'm going to add 18 to both sides, and I'm going to get 23 is equal to 3y, dividing both sides by 3, and y is equal to 23 thirds, which does not reduce, so that is my final answer. And in my, I just want to make sure, we need to double check this. Anytime we have fractional or rational expressions with variables in the denominator, we need to make sure that we can't get a 0 if we plug that in. Now if I plug in 23 thirds minus 6, that's not going to give me a 0. 23 thirds times 3 would give me 23 minus 18, also not 0, so we're good. Okay, in our next example, I have negative 7 over u plus 6 is equal to 3 over 5u plus 30 plus 2. So I'm going to put these fractional parts together. Oops, minus, because I'm switching sides, so that's equal to 2. Now if I look at these, I can see I can't have negative 6 as my answer. So as long as we don't end up with negative 6, we're fine. 5u plus 30 is equal to 5 times u plus 6. So I have u plus 6. If I multiply it by 5, I'll have a common denominator. So I have negative 35 minus 3 over 5u plus 30 is equal to 2. So negative 38 over 5u plus 30 is equal to 2. Again, this is going to be one of those situations where just switching places is very beneficial. 38 divided by 2, that gives me negative 19, is equal to 5u plus 30. I'm going to subtract 30 from both sides. I'm going to get negative 49 is equal to 5u. Divide both sides by 5, and you get u is equal to negative 49 fifths, which is not negative 6. So that answer is perfectly acceptable. Sometimes they're not even as complicated. We have 3 is equal to 1/4 minus 5 over z. Now there's a couple ways we can approach this as well. I'm thinking personally, my favorite method when you have fractional rational expressions like this with just one term in the denominator, I like to clear all the fractions. My common denominator is 4z, so I'm going to multiply every single term in the entire equation by 4z. Well, 3 times 4z is 12z. If I multiply 1/4 times 4z, the 4's cancel, and I'm left with a z. And if I multiply negative 5 over z times 4z, the z's cancel, so I get negative 5 times 4, which is negative 20. If I subtract a z from both sides, I get 11z is equal to negative 20. Divide by 11, and z is equal to negative 20 elevenths. Now another way we can do this is we can just deal with common denominators on one side of the equation. I need to multiply this one by z over z and this by 4 over 4, which will give me 3 is equal to z over 4z minus 20 over 4z. So that gives me 3 is equal to z minus 20 over 4z. And you multiply both sides by 4z to cancel. Those will cancel. And I get 12z is equal to z minus 20. Now you can see that this step here is identical to that step there. Subtract z from both sides. I get 11z is equal to 20, negative 20. Dividing both sides by 11, I get z is equal to negative 20 elevenths. For our next example, I have 2 is equal to 4/3 minus 5 over x. Now there's another way to do this. I can subtract 4/3 from both sides and subtract that from the 2. That's not the most efficient method, so I don't even really think we should take the time to go over that. To clear the fractions, my denominator, common denominator, would be 3x. Multiplying that by 2, I get 6x. Multiplying 3x times 4/3, my 3's will cancel, so I will get 4x. Multiplying 3x times -5/x, my x's will cancel, so I get 5 times 3, which is 15. I subtract 4x from both sides, so I get 2x is equal to -15. Divide by 2, and x is equal to -15 halves. Or we can just give each individual fraction a common denominator. Sorry, that should be times 3. So we get 2 is equal to 4x minus 15 over 3x. Multiply both sides by 3x. And I get 6x is equal to 4x minus 15. Subtract 4x. And you get 2x is equal to -15. Dividing by 2, I get the same answer. So again, there's method 2 or method 1. Either one works perfectly well. For our next example, I have quadratic equation in my denominator. Anytime I see a quadratic equation in my denominator, I want to factor it. So I'm looking for factors of 27 that have a difference of 6. Well, my only factors of 27 are 1 and 27 and 3 and 9. 3 and 9 have a difference of 6, and I want that 6 to be positive, so I'm going to do +9, -3. And that's going to be equal to -3y over y plus 9. Now, I have y plus 9 times y minus 3, so I need to make this times y minus 3 in order to have denominators that are like terms. And as a side note, if I have 5 over 12 is equal to some random number x over 12, my denominators are identical. The only thing 5 or x could equal would be 5. No other number would work. So now that I have identical denominators, I don't really need to deal with them anymore, except to know that y cannot equal -9, because that would give me a 0, or +3, because that would give me zeros in the denominator. Other than that, those denominators are now useless, because I know that this numerator has to be the same as this numerator if these two fractions are in fact equal. So I get -30 is equal to -3y over y minus 3. I'm going to multiply, distribute this. So I get -30 is equal to -3y squared plus 9y. Now to solve this, I need to set this equal to 0. So I'm going to do 3y squared. I just moved it, so now it's positive. And then I'm also going to move my 9y, so it's now negative. Minus 30 is equal to 0. All of these will divide by 3, so I'm going to factor that 3 out. If I divide both sides by 3, I'm left with y squared minus 3y minus 10 is equal to 0. I'm going to look for factors of 10 that have a difference of 3. That will be 2 and 5, and I want my 3 to be negative, so my 5 needs to be negative. Set each of these equal to 0, and I get y equals 5 and y equals negative 2. Combining my answers, I get 5 and negative 2, neither of which is negative 9 or negative 3, or sorry, negative 9 or positive 3, so we're okay. Let's try one more of these. 6 over y squared minus 4y plus 3, actually, we don't need to rewrite that. I'm looking for factors of 3 that will give me a sum of negative 4. Well, the only factors of 3 are 1 and 3, and luckily those add right up to negative 4. I have y minus 3 and my y minus 1, so I need to give this side a y minus 3. And again, I now have denominators that match perfectly, so we don't have to pay any attention to those other than to know that y cannot equal 1 or 3 because we can't have a 0 in the denominator. So 6 is equal to negative 3y times y minus 3. 6 is equal to negative 3y squared plus 9y, or I have 3y squared minus 9y plus 6 is equal to 0. I can factor 3 out. Now if I divide both sides by 3, I get y squared minus 3y plus 2 is equal to 0. So again, that's dividing both sides by 3. I'm looking for factors of 2 that add up to 3, and I want them to be negative. So I get y minus 2 equals 0 and y minus 1 equals 0. So I get y equals 2 and y equals 1. But up here, we said y can't equal 1. So this solution is invalid. So y only equals 2. And that is how you solve a rational equation